So in the last session, we were discussing questions related to Newton's law. We'll continue this discussion. And this was the last question. Okay, question 15. Basically, the questions are not in order, so we can simply use a page number for that. So this is page number 12. A student is asked to provide an explanation of why a bottle on the table remains stationary. Complete the free body force diagram. So if you want to complete the free body force diagram, first there is a downward force, the weight of the bottle, which is acting on the table, and then there is a normal contact force by the table on the bottle, which is acting upward. And one thing you should keep in mind that the length of the arrow shows the magnitude of the force. So if two forces have the same magnitude, so they should have the same length. So it is important that you draw the equal length or represent. So even if you draw in this manner, like you show the weight, say 2 centimeter, and then using a ruler again 2 centimeter line to show a normal contact force. But whenever the forces are balanced, the length of the arrow shows the magnitude. So you should draw the two arrows of equal length. The next part, that already we did on the diagram. Next part, the student writes the following incorrect explanation. So this is the explanation from the student, but it is incorrect. The student explanation contain errors. Rewrite the student's explanation correctly. So 3 marks. So first thing, when we read this statement, the force of the gravity pulls the bottle down. That's correct. The bottle pushes down on the table. The bottle pushes down on the table. So by Newton first law, the table apply equal and opposite force. So but that's wrong. It is not by Newton first law. It is by Newton's third law. According to Newton's third law, if forces are balanced, then nothing can move. So that is wrong also. According to Newton's first law, if forces are balanced, it's not about nothing can move. There are two possibilities. Either the object will be at rest or it will move with a constant speed. So when we rewrite the statement, after removing the error, what is the first error? The bottle pushes down on the table. So by Newton's third law, the table pushes up with equal force, and according to Newton's first law, if the forces are balanced, it's like not nothing can move. It is, if forces are balanced, then two possibilities are there. Either the object will be at rest or it will move with a constant speed. Is it clear, this part? So we have to identify the three errors. That's why it is of 3 marks. So 1 mark is for replacing first with third, 1 mark is for replacing third with first, and the last mark is for mentioning that nothing can move should not be there. It is the object can move, but it can move with a constant speed. The photograph shows a toy car driven by air from a deflating balloon. So when the air in inflated balloon is released, the car starts to move forward. Use Newton first and third law, explain the motion of laws of motion to explain why the air coming out of the balloon causes this. So basically what happened, according to Newton third law, as the air molecules are coming out, so there is a force by the car on the air, and that matches with, according to Newton, the forces always act in pair. So there will be a force by the air molecules on the car. And when there is a force, so when we consider the car, so because the car is having a resultant force, so if the resultant force is zero, the car will remain at rest. But because there is a resultant force which is not zero, then the car will start to move or it will start to accelerate. So the points which we will use to answer this: so according to Newton third law, the backward force on air by the car is equals to the forward force on the car by air. That's the first point, because as the air is released, the car is exerting force on the air, pushing the air, and air will also exert force on the car. Then the second point, if forces are balanced, the car will not move, and when the forces are unbalanced, the car will accelerate. So basically, as we already discussed yesterday, that the second law and first law are interrelated. If there is no resultant force, the object will not move. If there is a resultant force, if for a stationary object, if the resultant force is zero, the object will remain at rest. But if for a stationary object, if there is unbalance or a resultant force, the object will start to accelerate. So always try to use these statements. These are star questions, which means that the scientific terms which you are using, that is also important. The following a distance time graph. So as you can see on the figure, show that the maximum speed is between 100 to 150 centimeter. First, what we have to do whenever it is a curve, to get the maximum speed, what we have to do, we have to draw a tangent. So here the slope is increasing. At this point, the slope is maximum, because at this point the slope is maximum. So what we can do, we can work out the gradient of the tangent by using a formula y2 minus y1 over x2 minus x1 to get the speed at that particular time. So this will be y2, y1, x1 and x2, and finding the gradient, which is y2 minus y1 over x2 minus x1, will get the speed of this car. Then sketch the shape of the corresponding speed time graph. So we have a distance time graph and we have to sketch a speed time graph. So as we know, for a distance time graph, the slope represents the speed or velocity. So here, what the slope is representing speed or velocity. So first we have to check the pattern, the trend. So first, what is happening? The slope is increasing till what till this point. We observe that the speed is increasing, or slope is increasing. So if the slope is increasing, it means the speed is increasing. Then it is a horizontal line. it means the speed is constant. So the graph, as you can see, first speed is increasing. So what is this time interval? Say it is 1 point, each box is representing zero point 0.1. So 1.1, 1.2, 1.3. So till 1.3, I should show that the speed, and what is the maximum possible speed we get, because it is between 100 and 150. So it depends on what is our answer here. Example, if our answer is 120, so we have to use that value like 30, 60, 90, 120, and then 150. So we have to show that the speed is increasing. So from 0 to 1.3, the speed is 120, the maximum, and it is continued to increase because for a distance time graph, slope represents speed. If slope is increasing, it means the speed is increasing and the maximum value example is 120. Then for this time, a very short time interval, it is constant because it is a straight line. So like from 1.3 to 1.4, so for a very short time interval, it is constant. And then it is start to decrease as the slope is decreasing. So till this point, what is this time interval? It is 3, 1, 2, 3, 4. So that is 3.3. So till 3.3, it is start to decrease. So if slope is decreasing, the speed will also decrease. And then it is a horizontal line. It means the slope is 0. If slope is 0, it means the speed is 0. So how we sketch till 3.6, speed will be 0. Is it clear how we completed a speed time graph by using a displacement or distance time graph? So in exam, it can be other way around. Sometimes they give you a speed time and you have to calculate or sketch a distance time graph. So it vary. So you have to practice both. Another question. The photograph shows a solar powered model boat built by some technology students. This boat has a solar powered fan attached. The fan blow air towards the sail. So what happened? The fan is blowing air towards the sail. The technology student explained to a physics student that the fan exerts force on the air and the air then exerts equal force on the sail to drive the boat forward. Assume that these two forces are equal for the rest of the question. The physics student tells that according to Newton's law, it will not work. Identify the Newton's third law pair force with the force acting on the force of the fan on the air. So if force of the fan on the air, what will be the Newton pair force? The Newton pair force will be force of air on the, so force of fan on the air is there. So the Newton pair force will be force of air on the fan. So that will be the Newton pair force. A fan applying force on air, air will apply equal force but in opposite direction. The boat is placed in water, as you can see, and the fan is switched on. The boat remain at rest. So means the physics student was correct that it will not move. Add label arrows to the diagram below to show 4 forces acting on the boat in this situation. So what are the 4 forces? which are acting on the boat in this situation. Number one, there will be a weight which is acting downward, and because when object is on the surface of the water, so water will apply an upward force, and that is called the upthrust. So weight, and you should label them. Then there will be an upthrust, and equal length should be there because it's of same magnitude. Then the remaining two forces, one is the horizontal force, which is by the air on the force is there, which is exerted by the air on the fan. And the last one, there will be a force, the thrust, which is there, the force exerted by the air on the sail. But these forces are balanced because they mention here it is at rest. So if something is at rest, it means the resultant force should be zero. Use the Newton laws of motion explain why the boat does not move horizontally. So why this boat does not move horizontally? It should move according to technology student, but according to physics student, he suggests it will not move. So using a Newton's law, we have to explain that why it does not move. Basically what happened, the force which is there from the air on the sail and the force from the air on the fan are equal in opposite direction. So basically what happened, as you can see, look, fan exert force on the air, then air will push the fan. Same thing, when these air molecules exert force on the sail, so there will be a force on the sail is there, and there is a force on the fan. So, and these forces will be equal in magnitude but opposite in direction. So force of the fan on the air matches with the force of air on the fan. And same thing, force exerted by the air on the sail matches with the force exerted by the sail on the air. So you can clearly see there is no resultant. So if there is no resultant force is zero. If object is initially stationary, it will remain at rest. So force from air on the sail matches with force from air on the fan, and they cancel out each other. So the resultant is zero. If resultant is zero, it will not move. Is it clear this part? That why this does not move? Then the physics student suggested that the boat will move more likely to work if the fan is reversed to point in opposite direction. So if we change the position of the fan, like basically not position, we just change the direction of this. So instead of fan being placed on this side, it is placed on the other side. Now what will happen? Look, the fan will apply force on the air will apply force on the fan. And when we compare the sail only, the boat, now because with reference, because the force on the fan As the air is exerting force, like example, if I say a fan apply a force of 2 Newton, so there will be a 2 Newton force on the fan as well. And this 2 Newton force, same force is there on the whole board. So because there is a resultant force, so whenever there is a resultant force, the object will accelerate. So what happened basically, the force or push on air is which is away from the board, the backward direction. So there will be a force from the air on the fan which is in a forward direction, and that create a resultant on the board, and that resultant on the board will cause the acceleration, so board will start to move. So before there was no resultant force on the board, but now there is a resultant force. That is why the board start to accelerate. Then we have to calculate a volume. The mass is given in grams, so we have to convert into kilogram, divide by 1000, so it will be 0.13 kg. And so density is mass over volume. So volume is mass divided by density. Mass is 0.13 and density is 1000, so we'll get 0.13 into 10 to the power minus 3 kilogram per, sorry, meter cube, because it's a volume, so it will be meter cube. In question 12, on page 18, a student entering a physics classroom sees the following sentence on the board. So this sentence is written on the board. These sentences are being used as an example in explanation of Newton's third law. The car tire exerts a frictional force, a contact force of 300 Newton backward. The road exerts the contact force of 300 Newton forward on the car. State Newton's third law and explain how the sentence provide a good example of Newton's third law, pair force, and you can see the weightage, it's of 5 marks. So first, according to Newton's third law, forces always act in pair. Action and reaction forces are equal but opposite in direction. So first we'll write the statement for the Newton's third law. So every action force has an equal and opposite reaction. And according to Newton's third law, force should act on different bodies. So why this example is a good example? Because the force should act on different bodies. So as you can see in this example, the force act on the road and the tire. And another one is force is acting on the tire. Then they should be in opposite direction. And as you can see in this example, they mention the direction of the forces. Forward, backward, and forward. Then another, you can see they should have the same magnitude. I should write forces, not force, because it's the plural. And the forces should have same magnitude. and that is given example in this one, it is 300 Newton. And they should be same type, so you can see both are the frictional force. So this is how we'll score the 5 marks, that we compare basically with this example. We compare the Newton's third law. So the car exert force, the frictional force is there, that is one similarity. Magnitude is there, that's one is forward, one is backward, that is opposite. One is acting on the road, another one is acting on the tire. The first part is actually related to the fluid, so that we'll discuss later after completing the material and fluids. Okay. In this question, as you can see, the tilt of the wing, this is about how the bird can lift above the ground by using the wings. So the tilt of the wing result in air exerting a force on the wing which called a lift, and the lift force act perpendicular to the wing. The total vertical component of the lift produced by both wings when tilted is at a 20 to the horizontal, enough to keep the bird flying at a constant height. The mass of the bird is 0.63. This is the direction. Show that the total lift acting on the bird is about 1 Newton. So first what happened, it is like an incline, so the weight of the bird will act downward. So this is the weight of the bird which is acting downward. Then we resolve this weight into its component by taking the axis parallel to the surface. So when we take the axis, the angle of the inclined surface is same as the angle of the weight with the inclined surface, so that is 20. So the component of the weight which is with an angle, this is the component of the weight which is with an angle, so we call that as W cos 20. And the component of the weight which is against the angle, that is equals to W sine 20. So basically the lift is at a constant height, so it means the lift matches with W cos 20. The mass of the bird is given, the gravity is 9.81. So we can simply say that L is equals to W cos 20. And if W is equals to mg, so mg cos 20 is equals to lift. M is the mass of the bird in kilogram, which is 0.063. G is a gravity 9.81 and cos 20. So when we solve, we'll get the lift, which is about 0.66 Newton. Is it clear? Then the second part, assume that the only force acting on the bird are weight and the lift. Calculate the acceleration at that instant. So we have to calculate the acceleration. To calculate the acceleration, what we need a resultant force. So resultant force, which is equals to ma. So using the mass of the bird and using the resultant force, what we will get the acceleration. So but to get the acceleration, we should know the resultant force, the total resultant force. So here the weight which is acting downward having two components which are matches with the lift. So we have this formula. So this is the direction in which, because it is at the constant height or it is at a fixed height, so it's not going upward, but this w sine theta is responsible. Basically, this is the direction in which it is accelerating. So w sine theta is responsible for its direction of the motion. So what we can take, because we need the resultant force, so F is equals to ma. So direction of the flight is this. So that matches with w sine theta. We can say w, sorry, this is the direction of the flight. Then because we need the component in this way, so if this is a lift, if I complete this right angle triangle, as you can see, this will be 90. So this is 120, so this will be 70. Now the lift will also have the component, because we need the acceleration, direction of acceleration, so we need the force in this way. So how we can find the force? This is a lift which we already calculated, 0.66. So this angle will be 90. So the total sum is 180, so this angle will be 70. Now lift will also have the component of the lift which is with an angle, that will be, I will use another color. So the component of a lift which is with an angle, that will be equal to cos theta, and against the angle will be sine theta. Or you can also solve in this manner, like what you can do. This is a lift. Now if we resolve the lift into the components, so when I take the axis parallel to the horizontal surface, now I will resolve the lift into the component. So if this angle is 20, this angle will also be 20. And here, if we have this as 20, because the total sum, so this triangle is 20, so and remaining this one is 70, because the total sum should be 90 degree. So here at this point, what will be the angle? The angle will be 20 and this angle will be 70. So now, as you can see, this is a lift. The component of the lift which is with an angle, that is lift L cos 20, and the component of the lift which is against the angle, that will be L sine 20. So L sine 20 is a component of the lift which is responsible for acceleration. So resultant force is equals to ma. So L sine 20 should be equal to ma, and we'll substitute the value and get the answer for its acceleration. Is it clear, this part? Anyone having a doubt? Or you can also do in this manner, like this is a lift, you can extend this line. This angle will be 70 because the total is 90. So now this is a lift, the component of the lift which is with an angle. So it will be lift cos 70 and this will be lift sine 70. So in this case, lift cos 70 will be equal to MA. You will get the same answer. If lift cos 70 equal MA or lift sine 20 equal MA, both will give the same result. So in the next part, when some bird take off from the ground, there is no lift initially. So these birds pushes off from the ground with their legs, shows a graph. So basically what is happening, like when we compare the scale, say this is a ground and there's a bird on the ground. I'm representing by a rectangular box the bird. So example, the weight of the bird is 20 Newton. The ground will also apply a force of 20 Newton. So this is a contact force which is shown. So the contact force initially this, so basically this means the weight of the bird. Now what happened when we compare the scale, like this bird is also on the earth. So what is the Newton pair force for earth? The bird is experiencing a 20 Newton force. Bird will also apply a 20 Newton force on the earth. So both are applying same force but in opposite direction. But now to fly, what the bird do, it pushes downward. It apply more force. So when it will push the ground downward, example, a bird is applying a 10 Newton force. So now what will be the upward force? Because if the total 30 Newton is down, so 30 Newton will be up. But compared to earth, because there's a force of 30 Newton upward from the ground and the force of the gravity is 20 Newton, that is why this bird will start to accelerate upward. So here the bird is still on the ground, but when it's tried to push, why initially the weight decreases here or downward? Actually weight is not decreasing, but the downward force decrease. Why the downward force decrease? Because as the bird tried to push the ground, the position of the center of the mass changes. That's why for a short time interval the downward force decrease. But once it pushes the ground, as you can see, it pushes the ground, the downward force is increasing. So in this part, with reference to Newton's law, explain how the downward force from the leg enable the bird to take off. So how this downward force enable the bird to take off or lift? So bird legs exert a downward force on the ground. The ground will apply an upward force on the bird, and the upward force is more than the downward force. Like the upward force is more than the weight. That's why the bird will accelerate up. Is it clear, this part? Any doubt? So it's the same idea. That's how we are able to jump. We push the ground push us, and because the upward force is more than our weight, that's why we accelerate upward. So same thing happened. The bird pushed the ground downward, the ground apply an upward force, and that upward force by the ground is more than the weight of the